My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 599. In this lecture, we will try to understand convolution. To design convolution neural networks, first let's understand this concept called convolution. And we will understand this concept of convolution from the perspective of edge detection. Remember, edge detection is what are V1. Just try to recall, we discussed what is V1 in my previous lectures. V1 are primary visual cortex. Actually detects edges. Edge detection is one of the simplest mathematical operation. And we will first learn this, then we will build new things, and I will also introduce you a concept of convolution from the perspective of edge detection. Let's actually take a simple example. Let's take a 6 by 6 image. Let's assume I have an image like this. Let's assume it is a 6 by 6 image. Let's assume there is a region of the image like this which is fully dark. Let me say how many regions are there in this particular image. There are two regions. One is white and another one is dark. Let's assume that below region is black or dark. Lower half of the image is dark and upper half of the image is white. So this region is white, above half is white, this and below half is, I can say, black or dark. Now in this image, if I ask you, is there an edge in the image? What is my question? Is there an edge in the image? It's a small image. It is 6 by 6 image. If I ask you, is there any edge in the image? You would say, obviously, yes, there is an edge. There is an edge here because everything, just see, because everything above, just say this is a horizontal line, isn't it? There is an edge here because everything above this edge, and I can say it is horizontal edge, isn't it? Because everything above this horizontal edge is of one color, everything below this of different color. So you would say that there is an edge, isn't it? There is an edge here, isn't it? Now our goal is, given this, we take a simple example of 6 by 6 image. We will take a simple example of grayscale image. Let me say, what is this image? Grayscale image. We will come to color images later. Simple, for time being, let me consider simple grayscale of 6 by 6 image. What is the size of this image? 6 by 6. And we will learn how to detect a horizontal edge, isn't it? We will try to detect an edge. We will see how to detect. Let's understand what is the input. My input, and what is the input is 6 by 6. The input is simple 6 by 6 image. Let me just expand this 6 by 6 image so that I will explain what's happening here, isn't it? So this is my 6 by 6 pixel image. Let's actually write pixel values, isn't it? Pixel values here, because the lower bottom, just try to recall our image, lower bottom all black, isn't it? Let's assume all black pixels having the value 255. It's a grayscale image, isn't it? Grayscale image basically means it has values between 0 and 255. So I am just putting all these values. Wherever 255 is written, that pixel is black or dark. All the pixels that are white, I am just putting them a value of 0. Very, very simplified notation. So this is a simple grayscale image. Of course, you can also scale you can scale this your grayscale image. What is this? Its value is 0 to 255. You can scale this image to 0 to 1 by normalizing the image, because the maximum value, what is the maximum value? Maximum value is 255, minimum value is 0, isn't it? If I apply min-max type of normalization, what happens? You can just replace all these values 0 by 0 and 255 by 1, isn't it? 250 can be replaced by 1 and 0 will be replaced by 0 by using min-max normalization. Isn't it? Depends on how you represent your grayscale image. It always depends on representation of your grayscale image. Now, given this grayscale image, so these pixels are all white. Just see, these pixels are all white, these pixels are all dark. 0 values means white pixels, 255 means dark pixels. So actually there is a difference in color, isn't it? There is a difference in color from one region. Dark is, as I told you, dark is and dark or black is represented by 255, white is represented by 0, isn't it? So actually there is a difference in colors, isn't it? There is a difference in colors from one region to other region, from white region to dark region, isn't it? That's why my eye sees edge here. I can see the edge as there are two different colors, because there is a the difference in color between these two regions, this white region and black region. That's why my eyes see an edge. Now, how do you detect an edge? That's important. To detect an edge, we do is a simple operation. What is that operation? That operation is known as convolution operation. So this operation, when you do it on matrices, is no more multiplication. This is called convolution. This operation is called convolution operator. The star, people used to represent this operator star as convolution operator. I will explain you what is convolution. We will try to understand. Now, if I have other matrix, let me say I have other matrix. So let's say I have 3 by 3 matrix. This matrix is often called as convolutional kernel. This is not, you must understand, this is not SVM kernel. This is often called as kernel or filter or mask or operator. There are multiple names to it. It's often called as kernel, isn't it? It's often called as kernel. There are multiple names to this matrix. So this matrix, I have values, let me say I have values like this. I will explain you why these values and the things like that. Let's assume I have 3 by 3 matrix that has values like +1, +2, +1, 0, 0, 0, -1, -2, -1. First thing you notice the values in the first row. Just understand the values in the first row are same as the values in third row except for the sign, isn't it? The values in the middle row, if you observe, values in the middle row all are 0. So you have a 6 by 6 matrix. Let's call this is input. What is this image? Let's call this is an input image. So what is the task of edge detection? You are given an input image and you want to detect edges, and we detect edges by applying, what is the task here? We detect edges by applying convolution operator in the input matrix, because image is nothing but matrix. You can think of image is a matrix of pixels. Now this first one, 6 by 6 matrix, is an input image. This 3 by 3 matrix is kernel or filter. There is a special name for it. It is called, what is that? This particular of course input image is a matrix. What is this matrix name? 3 by 3 matrix name. There is a special name called Sobel edge detector. This 3 by 3 matrix in image processing is called Sobel edge detector, isn't it? To be more precise, it is called Sobel horizontal edge detector. Means which type of edges will it detect? It will detect horizontal edges. Let's see what it does. It's very, very important. You have this matrix. What matrix? Input matrix or input image, and you have this 3 by 3 matrix, that is Sobel Sobel horizontal edge detector. So the operation of convolution, what is this? This operation, if I apply this star, is known as convolution operation, isn't it? If I apply convolution operation in between input image and my Sobel edge detector or kernel, it will generate a 4 by 4 matrix. So it generates a 4 by 4 matrix. Let's see how it generates. Let me walk through you this with simple example, so that you will have much more clarity, and I will explain you why it creates a 4 by 4 matrix and how it creates matrix. And so first it says this is my kernel matrix. The 3 by 3 matrix is kernel or my filter, and my input matrix is of 6 by 6. So I will first try to place this 3 by 3 matrix, that is kernel matrix, on top of my input matrix. When I draw a 3 by 3 matrix, let me draw 3 by 3 matrix. First I will place this 3 by 3 matrix on input image matrix. Here I have values of 0, isn't it? Just see, well, here what am I doing here? Just observe. Just I am multiplying corresponding elements. Means first element is 0 in 6 by 6 and first element is plus 1 in 3 by 3. I am multiplying 0 into minus 1. Just I am multiplying these corresponding elements. Just I am adding. If I multiply and add, what will you get? So what are you doing here? You are multiplying corresponding cells. Multiply all of them and add them up. So this is literally, it is basically component wise multiplication followed by addition, isn't it? It is component wise multiplication followed by addition. This is very, very important. What value are you getting here? You are getting this particular value 0, isn't it? That's why I am placing 0 here. That we must understand, isn't it? Yes, this is very, very important. Corresponding cells will be multiplied, and when we multiply, what is the value we got? The sum of them is 0. If I multiply corresponding elements and sum of them, if I add all those corresponding multiplication, what value I am getting? I am getting 0. That 0 I am placing in 4 by 4 matrix in first entry, isn't it? If I take this 3 by 3 matrix, so when I use first 3 by 3 matrix, I got first time what I am doing, I am placing this kernel matrix 3 by 3 matrix on input image, and I am multiplying corresponding elements and summing them, and resultant value is 0. To fill next value, what is this next value? This is next cell. To fill the next value, what do we do? I will shift by 1. And now I will use this 3 by 3 matrix. Just I am shifting that right side by 1 position. Again, what am I doing? Again, component wise multiplication followed by addition, isn't it? Even that will result 0. Just if I do component wise multiplication and addition, what value you are getting? You are getting 0. Let's take a cell which does not result in 0. Let's take a simple case. Let's take this matrix, kernel matrix, 3 by 3 matrix, and I am considering, which one I am considering? I am considering this part. Which part? Anyway, I have already highlighted this part, just this one, isn't it? What is this? This. And where can I keep this one? I have to keep here, isn't it? Just what will you get if I multiply corresponding elements and if I add it? That resultant value is, what is that resultant value? Minus 1020, isn't it? So what is the sum of all of them? You will get a value of minus 1020. So you place value of minus 1020. Where will you place? I must place here. That's what it says, isn't it? Yes. Let's see another cell. Just let me consider. Just what am I doing here? Just what am I doing? I am taking my kernel 3 by 3. I am placing here, and I am placing an input image, multiplying corresponding elements, adding and keeping values. Just see, again 3 by. Just I am moving every window right side. This is first window, second window, third window, fourth window, isn't it? Each window is 3 by 3. I am placing this kernel from first position and moving it towards right by shifting one cell, so that how many values you are getting here? You are getting 4 values, isn't it? Let's this cell, what will you get here? Just what I have to do, I have to multiply corresponding elements and I must add it. What will you get? You will get these values. Just see, these are the cells, isn't it? This is a procedure. What am I doing here? What am I doing? Just I am doing component wise multiplication and addition, isn't it? What values? This is, if we keep on continuing this procedure, I will get these values, isn't it? Remember, we had a 6 by 6 input matrix. We have 3 by 3 kernel, and our output matrix is 4 by 4. Why is it? Why is it 4 by 4? Because I cannot create 6 by 6 output by using, I cannot create 6 by 6 input. Your input size is 6 by 6. Your output size is 4 by 4. I cannot create 6 by 6 output. Why? Because your kernel size is 3 by 3. I cannot create 6 by 6 output of it. How many 3 by 3 we have? If I have 6 by 6 matrix here, just observe in how many ways my 3 by 3 on top of your input matrix. This is first way, this is second way, this is third way, this is fourth way. How many ways? There are total 1, 2, 3, 4. That's why I'm getting 4 values. I'm for first, second, third, fourth. That's why I'm getting these values, isn't it? Same manner. Just say I'm getting first, second, third, fourth. In similar manner, I can continue here also. This is first one, this is second one, this is third one, this is fourth one. That's why I'm getting these values. That's why I'm getting other values, isn't it? I can place 4 times. I can only place 4 times. I can only place 4 times on row wise as well as column wise. I can even place 4 times in row wise as well as column wise, because I can only convolve. I can only perform convolution 4 times. Here my resultant, after performing the convolution operator with Sobel edge detector, what is the output? This is my output. What is output? This is my output. Just let me show. This is my output. Isn't it? This is the output that we got. Let's understand this output we will try to analyze why this is edge detector. That's an important. Why we are saying how it detects edge. Now just understand, time being, you are getting 4 by 4 output image by using this particular output. How we will decide about edge detection, how one can detect edges in given input image, that I will discuss in my next lecture, that is in lecture number 600. Time being, just try to understand how am I creating this 4 by 4 matrix by using 6 by 6 input image and 3 by 3 kernel. Thank you very much.